Hi, and welcome to my quadratic function lecture. And I'm going to share some ideas about what I believe quadratic functions are. What I have written here is the most basic one, f of x equals x squared. Now, this is called f of x is or equal to x squared. And uh, what I you could also write this as y equals x squared. Either way, they both mean the same thing. And before I continue about quadratic functions, I'd like to talk about linear because that'll lead into it. So I'll write that down here, and that's a linear function. And a linear function, we would call it f of x, our function, is equal to, let's say, x plus 1. Okay, so if I then say, well, what is f of 1? Well, that means it would be 1 plus 1 because wherever the x is, right there, I substitute. 1 goes in for x, and then that is equal to 2. And I would have the ordered pair, 1, comma, and 2. See, we would have that ordered pair, 1 comma 2. And then next, we would have f of 2 is equal to, well, it's going to be 2 now plus 1, which is equal to 3. And our ordered pair is 2 went in and 3. Oops. Trying to be consistent with my colors here. It's getting a little difficult. 2. So I had 2, comma, 3. And then I'll just do one more. F of 3 would be, well, 3 now goes in for x plus 1, which is 4. And we have 3 went in and 4 went out. Oops. 4 went out. So we have this now. If I bring this up, this is linear. And linear means you got a straight line. So I'm going to plug in these points here. We have, let's see, we have, oh, I got to get the whole thing in here. I got to move this over here. So this is Desmos, a graphing calculator. And we have, so 1 comma 2, 1 comma 2. So these become points. And then we have 2 comma 3. So we have 2 comma 3. And we have 3 comma 4. 3 comma 4. Okay, so this is linear. And we can see it's linear because it makes a nice straight line right through there. And further, I can tell you what this line is. The line is, should be y is equal to, what? X plus 1. So if I type that into Desmos, it should give me that line right through all of those. So I'll do that right now. And this will lead us into the other quadratic. So y is equal to x plus 1. Boom. Line right through there. Okay, so that's linear functions. They're straight lines. But we're talking about quadratics here. And the quadratic will be something different. So I'm going to bring this over to the other side here. And let's switch back over to our quadratic stuff. So the quadratic function, let's say I have this quadratic y equals x squared. Or it could be f of x is x squared. It really doesn't matter, but maybe I'll go with x and y this time. Now, if x was 1, what would I have? I would have 1 squared equals, now 1 squared is 1 times 1, which is 1. So y is 1. See right here. If x is 1, boom, y is 1. And so I will write 1, 1, 1. If x were 2, 2 squared is equal to 4. So my ordered pair now is x is 2 and y is 4. And if, just to remind you, the first number is always the x number and the second number is always the y number. So the x is 2 and the y is 4. Okay, I'll just do another one here where x is 3. 3 squared is 9. So that's 3 comma 9. And then 4. I'll stop at 4. 4 squared is 16. So you have 4 comma 16. And now, if I graph all of these order pairs, I have, let's see, let me bring this over. And I'll graph the order pairs. Let me put this in front. And this will go bring to front. And I can start typing these order pairs in. So we have 1, comma 1, and 2 comma 4, and 3 comma 9, 3 comma 9, and 4 comma 16. Okay, oops, comma 16. Okay, close parentheses. Now, when I look at this here, I can zoom out. You know what? I wonder if I could just make this bigger. Can I make this bigger? Yes. So as I make this bigger, and I look at this here, here are the numbers. Here are, let's see, I can't even see the, oh yeah, I can. So here, now this is not a straight line. It's a bit of a curved line here. And it turns out that that curve is what makes it quadratic. And since I have, since I have this right over here, this right here is our key right here, y equals x squared. If I type that into Desmos over here, which I'm about to do, so if I do that here, so it's going to be y is, I need to make this a little bit smaller. So y is equal to x squared. Hey, there it is. That line goes right through all the points. So when I have this here, the line goes through all the points exactly right there. A quadratic makes what's called a parabola. Oops, where's my, oh, here. It makes what's called a parabola. And it's this U-shaped curve. And the U-shape doesn't have to open up. It can open down, to the side, and all that kind of stuff. But when you first learn, it just opens up. Now, there's one other characteristic that I think is particularly interesting. And I need to kind of bring this out here. And if I return to my y equals x squared. So I'll bring this out here. And if I have, remember y equals x squared. So if I have, let's see, how can I write this? I think perhaps I'm going to rewrite this. Remember, all of these ordered pairs that are right here, all these ordered pairs, I'm going to rewrite these ordered pairs. But I'm going to do it a little bit differently to show something up. So let's say my x values and my y values. The x value, when I had 1, 1 squared was 1. When I had 2, 2 squared was 4. When I had 3, 3 squared was 9. When I had 4, 4 squared is 16. And what I need to do at this point is I need to take a look at the differences of the y values. So when I look at this, I see, hey, how much did that increase by? It increased by 3. How much did this increase by? This increased by 5. How much did this increase by? that increased by 7. And we see a little pattern here. You see the 3, then the 5, then the 7. So the next one must increase by 9, and it would, because 4 squared is 25. And maybe I'll write that down here. So to continue, 5 would be 5 times 5 is 25, and that's an increase of 9. So certainly that pattern develops. Now, a quadratic does this, where the pattern increases, and it increases by a certain amount, but it's different there. So now if we go a second layer deep, so what is the increase here? That increases 2. What is the increase here? That increases by 2, and that increases by 2. Now the fact that the second layer increases by the same amount, that's the quadratic right there. Right there. Every time it does this, you know you have an exponent of a 2 with the variable x. Compare that to the linear. When I bring this back over to that linear function, which was here and here. So remember my linear function. Now if I take all of these, here, and I do the same kind of thing. It's 1, 2, 2, 3, 3, 4. So let me bring that back over here. And I'm going to separate these by a big old line. Okay. Now the y equals x plus 1. The y values and the x values. So when I had x was 1, y was 2. When I had x was 2, y was 3. When I had x is 3, y was 4. And I could even go x is 4, y is going to be 5. And so when I have this, and I made this a little bit too low right here. I'll move this up. So if I look at this now, how much did that increase by? It increased by 1. How much did this increase by? It increased by 1, and that increased by 1. See, a linear function, you only have to go 1 deep, and you have that same number. It increased by 1, 1, 1, 1, 1, 1, 1, 1, 1, all the way through. That's a linear function. A quadratic, you have to do this 2 times. So, I wonder, the next one is called a cubic. So if you have y, I like it to do it in yellow actually. If you have y to the third, that's called a cubic. And I'm sorry, let me change this. If I had y equals x to the third, that would be a cubic equation, or if so, they call this an equation usually. Oops. They call it equation, but if I did f of x equals x to the third, that means the same thing. They would call this a function. So if I did this, if I had, let's just say I go with the equation, so I continue with the y value, the y value and the x value. So if I had x was 1, what would y be? Well, you think about it. 1. 1 goes in here. 1 times 1 to the third means 1 times 1 times 1. That's just going to be 1. It's going to stay 1. What if I had 2? 2 times 2 times 2. That is 8. 3. 3 times 3 times 3. That is 27. 4. 4 times 4 times 4 is 64. So this is all dealing with the x cube, okay? So let's take a look at this. How much did that go up by? It went up by 7. Let's see, how much did this go up by? That went up by 19, did it? Yes. And then how much did this go up by? Let's see, 3 plus 4 is 7. Okay, 37, I think. Okay. Now that's one level. If I go, oh, you know what? I better go to 5 here. So, or I can make this easier. I can say, what about 0? That would be a little bit easier. 0 to the third power is just 0. And that difference is, what that went up 1. Okay, so let's go to the second level. How much did this go up by? That went up by 6. How much did that go up by? That went up 12. And how much did this go up by? That went up by 18. Okay, and then we can do this one more time with this. This goes up by 6 and this goes up by 6. See? So the fact that we had to do this, did I use all my colors? I did. See, here's the difference. And then the difference between the difference in the third level, it's going to be 6 and 6 and 6 and 6 and 6. The fact that I have to do this 1, 2, 3 times, makes it a cubic. So I thought I'd just kind of compare that. Linear, quadratic, cubic. And so that's the basics of this. And I have there's wonderful patterns that I'll be working on, and I'll link to this video about quadratic patterns. Really cool stuff. So I hope that I've shed some light on this and given you some general knowledge about quadratic functions and what they do, what they look like. That's it. Thanks for watching.